This video will work through problem 15.8 from Gapenski's Healthcare Finance, 6th edition. Okay, in 15.8, we're presented with pediatric partners. They're trying to evaluate a project with these cash flows. So we've got three scenarios. We're given that each scenario, we've got a probability, and then their corporate cost of capital is 12%. So I'm going to make this just a little bit bigger. Okay, so the first question is, what is the project's expected base case? Whoops. So the way that your book likes to do the base case is to come up with the expected cash flow. So we would weight each of these cash flows and get the weighted average. So we've got 75 times 25, I'm locking that reference, plus 75 times 50% probability plus 75 times 25% probability. And then I just copy that down. And so my expected cash flows are this. So my expected NPV is, using the 12% cost of capital, I take my future values, my future cash flows, add that, the present value of my future cash flows, add that to my investment, and I come up with an NPV of 6566. Okay, so part B says, what are the project's most likely worst case and best case NPVs? So we just do the NPV, so NPV of the cash flows plus the initial investment. So that for bad, it's -18. And we've got for good, it's 27. And for great, it's 38. And then the scenario analysis asks, the only difference between, or to get the scenario analysis, we would just take the weighted average of the net present values of the scenarios. So we get E NPV equals the weighted average. So that's the 25% times -18 plus 50% times 27 plus 25% times 38 gives us 6566. And notice that they're the same as the expected NPV. Again, like I said, in 15.7, it's really just a matter of order. So what is the project standard deviation of the NPV? That's where we actually need these NPVs. So standard deviation, we start with the variance. All right, and the variance is equal to the probability times the difference between the expected and the NPV of the project minus the overall or the scenario minus the overall project's NPV squared. Let's see, I think I can just do lock that. Too much work. I'll just do it out. All right. Yeah. Sorry. Talking to myself while I'm talking to you. So I just do this probability times the NPV of the scenario minus the NPV of the project squared plus the probability of the third one times the expected NPV of the scenario minus the expected NPV of the overall project squared. And that gives me my variance, and then my standard deviation is equal to my variance, the square root of my variance. And so I get 20,475. And so then last part is uh, assume pediatrics partners, managers judge the project to have a higher than average risk. Furthermore, the practice's policy is to adjust corporate cost of capital up or down by 2 percentage points to account for differential risk. Is the project financially attractive? So, okay, so we're going to assume that this is riskier than average. So let's start by verifying. Okay, is the project financially viable given the base cost of capital? And the answer is yes, because the expected NPV, regardless of how you calculate it, is greater than zero. Okay, but now we're going to penalize this project by 2 points, 2 percentage points, because it's regarded as above average risk. So because we did this in Excel, it's very easy. I can just change the cost of capital, and that will feed through all my NPV calculations. So I change it from 12 to 14. And I still have a positive NPV, which means that, so despite the fact that I've raised the discount rate to account for the fact that the project is riskier than the um, uh, company average, we still have a positive NPV, still greater than zero. So therefore, this project is financially viable.